So in the last video we were basically stuck in this DMA configuration. The video has just get off by some technical problems. So here we will be continuing our DMA configuration. So these are the three different DMA configuration. The first is a single bus DMA configuration. In the single bus configuration, all the processor, the DMA, the IO devices, all are connected to a single bus. So it is simplest to build, but it is the most inefficient basically to run here. All the components, that is the CPU, DMA, memory and IO devices, all are shared in the one bus. So what happened is that the IO device from the DMA has to get the data from the IO device. So it is given, the IO device would give to an internal buffer which is there in the single bus to the DMA, and the DMA has to give it to the memory. So two times the system bus will be used. So if you see, when a DMA transfers a word, it first read it from the IO device which is there. IO device will give it the data, the word, to the bus, and from the bus it will be take to the DMA's internal buffer. Okay, then it has to write it from this buffer to the memory. So from the buffer to the memory means again I have to use the system bus again. So every single word would cost 2 full bus cycles here. So that means 2 times slower it become. So this is clearly inefficient because 2 times the bus is used, so it has become slower. So what is the because the first the IO device would write the data in the system bus and it will given to the DMA's internal buffer, and from there it has to give to the memory. So 2 times it is used, so therefore it is inefficient method, but it is simple to construct. And then the next thing is the second method is that it is also a single bus, but the IO devices has these, each IO device, if you see, they have their own integrated DMA with it. So here this double cycle problem is solved because the DMA's internal buffer has a stopping point. It is eliminating the DMA's internal buffer as a stopping point because the DMA controller itself is built directly into the device. So device means like the disk controller, the network controller, each of these devices has the DMA control built with it. So when a transfer need to come, the data can go directly from the device onto the bus and to the memory, right? Because DMA is already integrated with this IO device itself. So this is much more practical way. And then here you have the third configuration. In the third configuration you have 2 bus. You have system bus and IO bus. Each of these IO devices are connected to the IO bus, and in the system bus we have the processor, DMA and memory. So the DMA can communicate with these IO devices and get the data from the IO devices using the IO bus, and the DMA can transfer it to the memory using the system bus. So this is much more good method in which is commonly used in modern computer, because there are now 2 separate bus: the high speed system bus which is used only by the CPU, DMA and the memory, and a dedicated IO bus which is used by all of these peripheral devices. So the IO device can talk to the DMA over this IO buses, and the DMA can talk to the memory over the system bus. So these two conversation can happen simultaneously without blocking each other. So the CPU and memory can now exchange data on this system bus. This is what much more practical. This is which is most commonly used in the modern computer method. So these are the 3 configuration of the DMA. Thank you.